Welcome to today's Explainer. All right, let's jump right into a totally fascinating, highly specific spreadsheet today that's tracking COVID-19 VAERS reports. We're going to strip away all the noise and just focus purely on the raw numbers to see what the data is actually telling us. You know, when you're dealing with massive public health databases, the sheer scale can be, well, pretty overwhelming. But by isolating really specific data points, in our case today, reports that have been manually flagged as fake or inauthentic, we can actually learn a massive amount about the data set as a whole. So we're going to look closely at a very unique source document today, break down the math, and explore this gigantic gap between the total amount of information coming in and the absolutely tiny fraction of that information that gets rejected by the folks actively monitoring it.
Now, our source material today has let's call it a highly opinionated, completely unedited name, the batshit crazy VAERS Clearinghouse. Just to be crystal clear, we aren't here to take a side on the passionate debates around this topic. We're strictly here to impartially report on the mathematical reality found inside this specific document. But that title alone, it tells you the authors of this spreadsheet have a highly motivated viewpoint, right? They are extremely critical of certain entries. Keep that motivation in the back of your mind, because it actually makes the numerical data we're about to explore even more compelling.
So the absolutely crucial thing to understand here is the sole purpose of this document. This isn't just some random sampling or a computer algorithm doing an automated sweep. No, this is a spreadsheet explicitly dedicated to hunting for, tracking down, and cataloging fake or bogus entries amidst a vast sea of data. The individuals managing this clearinghouse are actively seeking out the anomalies. They are on a mission to find the bad data. And when you have highly motivated folks combing through a database looking for a specific flaw, the results they yield give us an incredible window into the overall integrity and composition of that entire database.
Moving on to millions of total reports and setting our baseline. Because in any data analysis, before you can really grasp the significance of a small number, you have to clearly define the massive denominator you're operating within. And as of May 31st, 2024, this clearinghouse notes a staggering 1,640,416 total COVID-19 VAERS reports in the system. Just let that sink in for a second. Over 1.6 million individual reports. That is an absolute mountain of data. It represents an incredible volume of submissions collected over a multi-year period. This number right here is our macro view. It's the grand total of everything sitting in the system at that specific point in time in late May of 2024.
Which brings us to the bogus fraction. We're zooming in now. We've established our massive denominator, so it's time to check out the numerator. We're looking for the exact number of reports that these dedicated, highly motivated individuals have successfully flagged as undeniably bogus.
Out of those 1.64 million reports in May 2024, only 350 were actively flagged as bogus. Just 350. When you're navigating a data set of over 1.5 million points, 350 is, well, it's an incredibly minute figure. It's a stunning drop-off from the total pool of data. Remember the whole premise of our source material here? This is a clearinghouse run by people actively trying to find these bogus reports, and after scouring that mountain of 1.64 million entries, the total yield of bad data they managed to flag sits right at 350.
And check out how perfectly static these numbers remained over time. Back on January 20, 2024, there were roughly 1.6 million total reports, and exactly 351 were flagged as bogus. Fast forward over 4 months later to May 31st, 2024. The total reports have grown to exactly 1,640,416, but the bogus count is just sitting there at 350. Over a third of a year went by, the database continued to intake information, and yet the number of identified bogus reports essentially didn't budge. Actually, it technically dropped by 1, probably because they reevaluated a previously flagged report.
So even with a relentless, ongoing effort by people actively looking to expose fake entries across a 4-month stretch, the total report sat steadily in that 1.6 million range, while the bogus count flatlined right at the 350 mark. They simply aren't finding new ones at any measurable rate.
The contrast in scale here is so massive that the human brain honestly struggles to intuitively grasp the difference. It's the ultimate David and Goliath scenario, mathematically speaking. The total mass of data vastly outweighs the flagged anomalies. When you're comparing a number in the millions to a number in the low hundreds, you really start to appreciate the true weight of that baseline versus the tiny fraction of identified errors. When you actually map the 1.64 million non-flagged reports against the 350 bogus ones, that flagged slice is so phenomenally small it almost vanishes entirely. It's a massive universe of data containing a practically invisible fraction of confirmed anomalies. The sheer volume of the data set just swallows up the verified bad data. It's virtually imperceptible.
Doing the exact math provided by the source, if you divide 351 by roughly 1.6 million total reports from that January snapshot, it leaves us with a minuscule proportion of just 0.0002. That is 2/10,000ths, a mathematical expression of almost zero.
And context is absolutely essential here. This tiny 0.0002 fraction isn't the result of some random audit that accidentally stumbled onto a few errors. No, this number is the direct result of dedicated individuals actively scouring the data, with the explicitly stated motivation of finding and flagging these specific bogus reports. They went looking for a massive problem, and despite their best highly motivated efforts, the verifiable mathematical output of their search is 0.0002. The effort was maximum, but the yield was microscopically minimal.
So I want to leave you with this final thought to ponder as we wrap up today's explainer. We've looked at the source, we've established our massive baseline of 1.6 million, and we verified that tiny static numerator of roughly 350. When the number of explicitly identified bogus reports, found by people highly motivated to expose them, remember, is mathematically this microscopic, just 0.0002, how should that shape our perspective on the larger database? Does a fraction that small undermine a system, or does the sheer difficulty of finding those bogus reports actually speak volumes about the rest of the data? Think about that math. And until next time, keep seeking clear answers.